Hello students, today we are going to deal with joint diastole, isovolumetric, relaxation, contraction and joint systole, why it can't happen. So let's begin. First of all, what is joint diastole? Simply you can understand joint diastole as both atria and ventricle diastole, both of them are relaxed, that is called joint diastole. Got it? Now in this phase occur after ventricle have finished contracting and before atria contracts. One more point that I have to mention here, that whenever the whole pie chart, I hope you all remember, whenever the atria is contracting, then it is contracting, but for rest of the 0.8 second, okay, 0.1 second it is contracting atria, for rest of the time 0.7 second when ventricle is doing something, the atria is continuing contraction. Similarly for ventricle, for 0.3 second it is contracting, but after after all the time, rest all the time, which is 0.4 second, it continues relaxing. Okay, now what happens in joint diastole? First of all, relaxation of both chamber happen, then feeling of hurt happen. So basically the AV valves are open and hence the passive flow of blood from atria to ventricle occurs. So let me show you. After this ventricular systole, what happens is the ventricle start relaxing and it gives all the blood to it gives all the blood to arteries, and hence this relaxed phase is there, and this relaxed phase is continued till arteria start contracting. And when artery was not contracting and ventricle was relaxing, we call that phase as joint diastole. Okay, then we have isovolumetric relaxation. You can just remember this as it is the phase when only and only ventricles eject, ventricles relax, and after ejecting blood, means after contracting they relax. So what happens is the ventricle relaxation begin. First of all, the ventricles start to relax after contracting and ejecting blood, and then SLV valve close. Why? Because the pressure in arteries rises as the pressure in ventricle drops, because it is relaxing. Afterwards all the valves are closed. AV valve was already closed, but now also AV valve is closed, so there is no volume change. As you can see, there is no volume change, and this phase ends when the ventricle pressure drops too much that the arterial pressure is higher than the ventricle pressure. So arteries AV valve opens, and AV valve open, and then what happens is blood flows from arteria to ventricle. This is how the whole isometric relaxation takes place. After ventricle systole happen, means ventricle systole is this one. So after this happens, what happens is ventricular diastole, and this is written isometric relaxation. So first of all, correct it is isovolumetric relaxation. And one more thing, that this I just want to show you, that in this isovolumetric relaxation all the blood has gone to them and nothing is coming here, because the pressure is not too much, so that pressure is not too low that it becomes less than the arterial pressure, and hence the blood is not flowing into. But after, when the arterial pressure rises, then what happens is the ventricle diastole happen, as you can see. And this is called joint diastole also, because it is also relaxing, but afterwards what happens is the pressure is too high in this. Then what happens is the all blood start ejecting, means it starts systoling. And as I told you, when it is systoling, it is not diastoling, which means if arteria is systoling, then it is only systoling, but when it is not systoling, it is diastoling. This is how you can understand the things. Now I want to tell you what is isovolumetric contraction. It is just the phase of cardiac cycle which occur after ventricle have filled with blood and before they start ejecting it. It means they start systoling. So when they start systoling, obviously when they are not diastoling. So this is how in this phase what happens is ventricle contract. And when I'm talking about isovolumetric thing, then we only consider ventricles. Okay, so ventricle contract with no volume change, that's why it is isovolumetric, means no volume, same volume change, no volume change and same volume, because the pressure inside the ventricle increases but the semilunar valves are closed, so there is no change in the volume but pressure change happens. First of all, what happens is ventricle diastole happen. ventricle systole happen, which is contraction begins. So obviously there is some electrical impulse signal. So basically electrical impulse from SA node transfers to AV node, then it transfers to bundle of His, Purkinje fiber, and finally it reaches ventricle. After that, as the pressure begin to rise, then AV valve closes because the pressure of ventricle exceeds the pressure in atria. Then all the valves are closed because both are closed, SLV valve and AV valve, semilunar valves and AV valves, both are closed. And pressure in ventricle increases because they are contracting, but there is no volume change because all the valves are closed. And afterwards, when pressure increases so much that it exceeds the pressure in arteries, then what happens is blood start flowing from ventricle to arteries, great arteries. Now my last question, why joint systole can never happen? Because joint systole means both are systoling at the same time, and this cannot happen because obviously the Hertz electrical conduction system and this careful timing is fixed. So we just have to look into it in great detail. So let's go. First of all, we know that SA node generates the electrical impulse, and this is then transfers to AV node. After that, AV node delays the electrical impulse to allow artery to first finish contracting, and ventricles to fill it with blood. And afterwards, they do not, this delay allows them to not contract simultaneously. After this delay, what happens is the impulse is transferred to bundle of His, then it is transferred to Purkinje fiber. Afterwards, this sequence of transferring ensure that artery contract first and then followed by ventricle. So artery will contract first, and till the time it is contracting, ventricle will diastole. And once they have completed contracting, now it's time for ventricle to contract. Okay. Now why is it so important? Because this is functional necessity for efficient blood flow, because if both of them contracted at the same time, then what will happen? Ventricle would not probably fill with the blood. Okay, it wouldn't be able to fill it with itself with the blood, and the heart would be unable to fill. Actually, the pump of blood will not happen throughout the body because obviously ventricle is not able to fill it with blood. So that's how this is not possible. Joint systole can never ever happen. Now let me summarize everything for you to make it more simpler and easier for you. So basically what happens is, first of all, ventricle starts systoling, means ventricle systole happens, which means the ventricle is pushing blood into arteries, and ventricle is contracting. So it's pushing of blood takes place, means contraction of ventricle takes place. After this contraction, what will happen is obviously they'll relax. So isovolumetric relaxation happens. So what happens in this, we all know that blood does not enter into this and blood does not exit, so its volume remains same, hence it is isovolumetric relaxation. Mentioned in here, it's isovolumetric relaxation, and the ventricle is relaxing right now. Whenever we have isovolumetric, we just deal with ventricle, so it's just relaxing right now. And we also know that the blood, it's relaxing, but the pressure is dropping. Now after the pressure will drop, what will happen is the pressure in artery will rise, and after this what will happen is simply isovolumetric relaxation is completed. Now joint diastole will happen. Both of them are diastoling, which means both of them are relaxing. This systole has happened. Okay, ventricle systole has happened. Now ventricle diastole is happening. At the same time, whenever it is not systoling, artery is not systoling, it is diastoling. So both of them are diastoling at this time. So what will happen is joint diastole will happen, but after joint diastole we'll be able to see that the pressure in this, because why the pressure in this will drop, because the pressure is decreasing, as we know that all the blood was transferred into this by in the isovolumetric relaxation. So pressure was dropping, but this valve was not open. But now the pressure dropped to such an extent that the pressure in this artery rise, and hence the passive blood flow happens. But this is not contracting, artery is not contracting, artery is also relaxing. Remember my words, whenever artery is not contracting, it is relaxing. So here also it is relaxing, and in this case here also it was relaxing, that's why it is receiving the blood. So 70 to 80%, as you can see here it is written 70 to 80% blood filling happens due to ventricle diastole, which is during joint diastole, I would say. And after 20 to 30% of blood filling happens during arterial systole. Got it? Now after this, what happens is simply they start systoling, the arteries start systoling and contracting, the blood, all the blood get transferred to ventricle, and after transferring all the blood, what will happen is this will start contracting. Ventricle will start contracting and will again see isovolumetric contraction. Now this correct it, please, it's isovolumetric contraction. And one more thing you'll notice here, that the blood is not going into this and the blood is not going into this, but the pressure is increasing. So pressure is increasing, therefore the pressure is increasing, but the pressure is not till such extent that it will become greater than the pressure in arteries. So this is just increasing pressure, but volume is not changing, so it's isovolumetric contraction. After this, again what will happen is ventricle systole will happen. It will give all the blood to great arteries, and again after it we will see isovolumetric relaxation, when no blood is coming in and coming out in ventricle, and but it is relaxing, so pressure will get dropped. And then after, what will happen, joint diastole will happen, and afterwards arterial systole will happen, and finally it will continue again and again. So let me just summarize it in one page. This is the whole process. Basically, first of all, ventricle systole happens. As you can see in this picture, that ventricle systole is happening, right? The ventricle is pushing all the blood into them, okay? What happens after it? Obviously it will then start relax, because whenever the ventricle is not systoling, it will start diastoling. Now after it we have ventricular diastole, so it starts relaxing, but we all know that valves are closed, so there is no change in the volume. So isovolumetric relaxation will also happen in ventricle, okay? After isovolumetric relaxation, joint diastole happen when arteria and ventricle both are diastoling, which means whenever arteria is not systoling, it is diastoling. And we also know that ventricle is diastoling, so both of them are diastoling, hence isovolumetric relaxation. Diastole of joint diastole takes place. After then we again have the arterial systole. As you can see in this figure, that artery starts systoling and giving out all the blood to ventricle. Then isometric contraction takes place, which means ventricles start contracting, but no blood is coming out and going out, hence the volume is remain same. So first ventricle systole happen when all the blood is pushed into great arteries. Then ventricle diastole happen, also ventricle is diastoling at the same time, no blood is going out and in. So what is happening is isovolumetric relaxation is happening. Then you can note that both of them are diastoling, because whenever artery is not systoling, it is diastoling. And also we know that ventricle is diastoling, so joint diastole takes place. After that, what will happen is arterial systole will take place, because pressure in ventricle will drop to such an extent that this will start pushing blood into it, and hence the arterial systole will take place afterwards. After then we have the final stage, is isovolumetric relaxation. Here the blood is not going out, coming in, just the pressure is increasing, but it is not going out or coming in. Now the pressure will increase to such an extent that it will become greater than arterial pressure, and hence you can see the blood start going into the great arteries, and hence the ventricular systole will take place. This is how you can see that ventricle systole take place. After that, ventricular diastole, after isovolumetric relaxation, then joint diastole, then arterial systole, and isovolumetric contraction. This is how you can distinguish between joint diastole, isovolumetric relaxation, and isocontraction, and the why this doesn't happen, joint systole doesn't happen. Now I hope every doubt is clear. Thank you so much for watching. Bye.